Okay, let's take a look at finding the domain of this rational function x plus 4 over x squared plus 11x plus 28. Any rational function has a numerator polynomial over a denominator polynomial. We'll call the numerator polynomial n of x, the denominator polynomial d of x. So the domain is determined by the denominator polynomial, which cannot be 0. So x squared plus 11x plus 28, which factors into x plus 7 times x plus 4, cannot equal 0. So that means x plus 7 can't be 0, and x plus 4 can't be 0. Which means x can't be negative 7, and x cannot be negative 4. All right, so we want to talk about, when we give the domain, we talk about what x can be. So if we were to make a number line graph, we would be omitting negative 7, so I put a open circle above that to show that's not part of our domain, and we would be eliminating negative 4. So these are the only two values x cannot be, but x can be anything to the left of negative 7. That's shown in the interval negative infinity to negative 7. Anything between negative 7 and negative 4, which is the interval negative 7, negative 4, or anything bigger than negative 4. So that's the interval negative 4 to infinity. So this is the domain of f of x. All right, so we want to simplify our function if that's possible. Whenever we simplify our function, we factor the numerator and denominator. Can't factor x plus 4, but we can factor x squared plus 11x plus 28 into x plus 4 times x plus 7. So we see we have a common factor of x plus 4 that divides out. So the numerator x plus 4 divided into x plus 4 is 1, and the denominator is now simply x plus 7. And this is our simplification, and we're going to call this g of x. So g of x and f of x are the same as long as when I divide it, notice I divide it by x plus 4, as long as that wasn't 0. So these are the same as long as x is not negative 4. So we now want to find any missing points or vertical asymptotes of the graph. And we do that by evaluating the function for the values of x that make the denominator 0. So we had negative 7, and if we evaluate the function when x is negative 7 in the numerator, we get negative 7 plus 4. We know that value makes the denominator 0. So we get negative 3 over 0, which is a non-zero number over 0. Whenever a number put into our rational function gives us non-zero over 0, x equal to that number, which in this case is x equal to -7, is a vertical asymptote. The other number that made the denominator 0 was -4, so we'll evaluate the function at x equals -4. So we get in the numerator -4 plus 4, and we know -4 makes the denominator 0. So we wind up with 0 over 0. So that means there's a missing point or a hole at x equals -4. So to find the y value of the hole, we use the simplification of the function. So we take g of x, which was 1 over x plus 7, and we replace all the x's with -4, since that's where our hole is. So we wind up with 1/3. So we have a missing point or a hole in the graph at the point where x is -4 and y is 1/3. All right, if we want to give the horizontal asymptotes of the graph, we look at the degree of the numerator, which we called n of x, and we know that that's 1, which is less than 2, which is the degree of the denominator. So we compare the degree of the numerator to that of the denominator. And whenever the numerator degree is smaller than the denominator degree, the horizontal asymptote is y equals 0, better known as the x-axis. All right, so that's problem 1. Let's look at problem 2. Problem 2, we have the rational function f of x equal 5 over x squared plus 11x plus 28. Now, since this denominator is the same as the denominator of problem 1, so when the denominators are the same, then the domain is going to be the same. So we don't have to do any additional work to find the domain than what we've already done. So the domain of f of x, since the denominator is identical to the previous problem, are all the numbers left of -7, united with all the numbers between -7 and -4, united with all the numbers to the right of -4. All right, when we go to simplify this function, we find that we cannot simplify it. To simplify, I factor numerator and denominator. So I can't factor the numerator, but the denominator factors into x plus 7 times x plus 4, which has no factors in common with the numerator. So we can't simplify this. And then part C, we want to find any missing points or vertical asymptotes. These are only going to happen at the values that make my denominator 0. So I need to consider f of negative 7. And notice that's going to give me 5 over 0 because the numerator is always 5. And I know negative 7 makes the denominator 0. So this is a non-zero value over 0. So x equal negative 7, whenever I get a non-zero over 0, the result is that x equal to the value I was putting in is a vertical asymptote. Similarly, if I let x equal negative 4 in this case, I also get 5 over 0 since negative 4 makes the denominator 0 and 5 is always the value of the numerator. So I get non-zero over 0. So x equal negative 4 is a vertical asymptote. And then finally for this problem, I want to give the horizontal asymptotes. Well, those are found by looking at the degree of the numerator, which we call n of x, which in this case is 0. The numerator had no variables in it, so its degree is 0. And that's smaller than 2, which is the degree of the denominator. So whenever the numerator degree is smaller than the denominator degree, the horizontal asymptote in that case is y equals 0, better known as the x-axis. All right, so let's go to the next problem. Problem 3. I have f of x equals x squared plus 11x plus 28 over x plus 4. So to find the domain, I always look at the denominator. So my denominator, x plus 4, cannot be 0. That means x cannot be negative 4. So when I think about the number line, I'm only excluding one number, and that's negative 4. All other real numbers will make this function defined. So I want all the numbers left of negative 4, which are negative infinity to negative 4, not including the negative 4, or all the numbers bigger than negative 4, which is the interval negative 4 to infinity. So this is the domain of f of x. All right, now I want to simplify this if possible. So I factor numerator and denominator if possible. I know the numerator factors into x plus 7 times x plus 4, and the denominator is x plus 4. So I have a common factor in the numerator that's also in the denominator that I can divide out. And as long as this x plus 4 is not 0, f of x will equal x plus 7, which I'll call g of x. So let's list any missing points or vertical asymptotes. So there's only one value that made the denominator 0, and that was negative 4. So that's the only value I need to check for part C. So I get I know x equal negative 4 makes the numerator 0 because it has an x plus 4 in it, and it also makes the denominator 0. So I got 0 over 0. Whenever my input value gives me that result, that means I have a hole or missing point at x equal negative 4. So I'll need to find the y value, and I'm simply going to use the simplification g of x to do that. So remember, g of x is equal to x plus 7. So g of negative 4 is negative 4 plus 7, which is 3. So the hole in the graph is negative 4, 3. Okay, now I want to find the horizontal asymptote. And I do that by comparing the degree of the numerator to the degree of the denominator. So the degree of the numerator is 2, because I had a second degree polynomial. And that's smaller than 1, which is the degree of the denominator. Alright, so whenever the numerator degree is bigger than the denominator degree, there is no horizontal asymptote. So let's look at problem 4. Here I want to give the domain of this function whose denominator is x squared plus 10x plus 21. So that cannot be 0. And that factors into x plus 7 times x plus 3. And if I set those both not equal to 0, I get x can't be negative 7 and x cannot be negative 3. Okay, so we want to talk about what x can be. Well, x can be anything to the left of negative 7, any number between negative 7 and negative 3, or any number to the right of negative 3. So that would be my domain. Okay, so the key there is you have to look at the the denominator to find the domain of the function. Okay, so we want to simplify the function. So we write it in, we factor the numerator and the denominator to simplify. So f of x equals, so I see that I can factor GCF out of the numerator. So 2 times the trinomial x squared plus 11x plus 28. And then the denominator, we know, factors into x plus 7 times x plus 3. And then we can factor the numerator again to get x plus 7 times x plus 4. We can divide that by x plus 7 times x plus 3. And we divide out the common factor x plus 7. So the simplification equals 2 times x plus 4 over x plus 3. And again, we'll call that g of x. These two functions are the same as long as x plus 7 isn't 0, which is the same as saying as long as x is not negative 7. So our simplification g is 2 times the quantity x plus 4 over x plus 3. Okay, and we want to list any missing points for the function. So we're going to do that by evaluating the function at negative 7 and negative 3, since those were the values that made the denominator 0. We have to make sure we use the original function here. So I'm going to use this factored form, 2 times x plus 7, but I'm replacing x with negative 7, times x plus 4, replacing x with negative 7 is negative 7 plus 4, over, and I know these values that I'm testing make the denominator 0. But notice, negative 7 plus 7 is 0. So you get a 0 out of this. So the function evaluated at one of the values that makes the original denominator 0 gets 0 over 0. So that tells me there's a hole at x equal negative 7. To find the y value of the hole, I take negative 7 and put it into g of x, which is my simplification. So 2 times negative 7 plus 4 over negative 7 plus 3, which is 2 times negative 3 divided by negative 4. So I have negative 6 over negative 4. If I divide both of these by negative 2, I get 3/2. So I have a hole in the graph, if I were to graph this, at negative 7, comma 3/2. Finally, we want to give the horizontal asymptotes of this function. Well, we want to compare the degree of the numerator which was 2, to the degree of the denominator, which also was 2. So whenever the numerator and denominator have the same degree, the horizontal asymptote is y equal the degree of the leading term, not the degree, I'm sorry, the leading term over of the numerator over the leading term of the denominator. These x squareds divide out to give 1. And we have y equal to 2 as our horizontal asymptote.